In this video, we're going to be covering derivatives and indices. So when we're differentiating, it's important to convert our terms to index form. So what I mean by that is if you have the square root of x, we actually want it to be in x to the power of a half. If we want it, if we have the cube root of x, we want it to the power of 1 over 3. And if you have a fraction such as 1 over x to the power of 2, we really want that in x to the power of negative 2. These make differentiating a lot easier and simpler to do. Another one that I did miss on here is what if I had something like 3 root x to the power of 2. That ends up being x to the power of 2 over 3, just for completeness there. So let's go to the first example. We're going to differentiate 6 root x. So the first thing we want to do is convert that to its index form. So if we have 6 root x, that's going to be the same as x to the power of 1 over 6. So if I differentiate that, so if we have fx equals x to the power of 1 over 6, remember the power comes out the front and then you minus 1 off. So my derivative is going to be 1 over 6 x and then 1 over 6 minus 1. So we end up with 1 over 6 x and then negative 5 over 6. Now you could leave it like that. Sometimes you will be required to return it to its original form. So if I do that, we end up with 1 over 6. The negative up here, we're going to focus on that negative first, which means we turn it into a fraction. So we end up with 1 over x to the power of 5 over 6. I'm now going to focus on the fraction part of that index. So we end up with 1 over 6 times 1 over 6 root x to the power of 5. And then we can times those, and remember when you're timesing fractions, times the top times the bottom. So we end up with 1 over 6, 5. All right, so if you did need to return it, remember the same rules applies when you're going from a root to an index form. So here we have another one. Find the derivative of y equals 3 over 2x squared at the point 1 and 1.5. So we have y equals 3 over 2x to the power of 2. I want to convert that to index form where I don't want a fraction there. I want everything at the top. So I end up with y equals 3 over 2 x to the negative 2. I don't need to bring the 2 up as well. I just need to bring the x up. The x is the only thing that needs to be brought up. So if I go and differentiate this, that 3 over 2, it's a constant. It's going to stay there. The negative 2 is going to be brought out the front. So times negative 2. We get x, and then we get negative 2 take away 1. Let's simplify that. So we end up with negative 6 over 2 x to the negative 3, which we can simplify more. So we get negative 3x to the negative 3. All right. Now the second part of this question said, because the question said find the derivative of this at the point 1. So we're going to go and substitute in. So we're going to let x equal 1. So we end up with negative 3 times 1. You don't need to put the brackets. I like to put the brackets just so I know where my substitution's going. Then you can put that straight into a calculator, and you end up with negative 3. So the gradient at 1 is going to be negative 3. So sometimes you'll see that as left as dy over dx. Sometimes you'll see m equals that. Or like I said, sometimes you'll also see that. Each one of these mean the same thing.